Thanks for joining us. We're taking a look at our Ambu bag emergency ventilator equivalent. Wanted to show you guys how we put this project together. We've been working on it for the past several weeks with a good team of engineers in mechanical, aerospace, biomedical, and myself, even construction. Wanted to develop a product that we could use rapidly in the event of an emergency using off-the-shelf parts only. That would help keep respiratory functions going while first responders could come to the aid of a victim. And this is what we came up with. So taking a look here, I wanted to show you guys the inhalation side. This is the final product, just a preview of what we're going to be putting together today. This is the exhale side of the project, and so when a patient exhales, what does it do? And this is the exhale side in reality, what it looks like, how it functions, and you'll see that in the video here in a little bit. These are all the parts we used. This is what we ended up with for our project, and I'll start assembly here very quickly. Prior to the assembly, I'd like to show you guys the clinical requirements that were given to us by our amazing respiratory therapy team. Worked with several respiratory therapists who gave us our guidelines and design parameters, along with our engineering team's design and manufacturing requirements. We had these in place to help make sure the device could actually be useful to those in lower resource and developing countries. Hello, and thank you for joining me. Today I'm going to show you how I would build a temporary Ambu bag equivalent using only off-the-shelf parts that I was able to find. With the exception of the valves and filter, which we're still working on as well. But I was going to show you guys how I put this together using simple household tools. Things you'll need: a pair of needle nose pliers with wire cutting capabilities, flathead screwdriver, crosshead screwdriver. We'll need that for the electrical. Box cutter or something to cut vinyl lining or hoses with, a wrench, preferably a larger one if you have to take things apart, along with another wrench as well if you have to take anything apart or tighten things down. And I've got a measuring tape that measures in centimeters, as we're going to be using centimeters of water. I'll also give you guys the equivalents in inches as needed. There's the two valves that are from California. Other than that, we've got all the parts here. We've got an air regulator, things like this. We'll start at the back, and so assembly here, we're going to start with getting the air into the system. And so this is the air pressure regulator. There's an import on one side and an output on the other. We're going to thread in 1/4 inch air compressor quick connect under the 1/4 inch inside of the air compressor and tighten it down. And this is if you're using an air compressor to feed the device. That 1/4 inch port could, obviously you can get a brass bushing if you want to utilize a different sized air port, or you need to thread something else in. Luckily the 1/4 inch side as well is the same size as the medical air fittings that we've seen in the industry, so it should thread right into the regulator as needed. The next thing you're going to install, this is the 1/4 inch coupler or nipple. And this is going to allow us to attach the regulator to the back end of the device. Now that's nice and tight. We're going to install the pressure gauge, and the regulator that we chose doesn't come with a pressure gauge off the shelf. We're going to be using our 5 psi pressure gauge here. You can use between 5 and 10 psi gauge. This one has a 1.5% accuracy range, so it's pretty accurate. It does need an adapter here, and so we've got a bushing here that goes from 1/4 inch to 1/8 inch. The port on the regulator is an 1/8 inch port, and there's only one port that is an 1/8 inch size on the regulator, and so we'll thread that in there. Also, as you guys are doing all these different fittings, some of them come with some sealant already on the fittings for the air compressor fittings, things like that. I recommend you also get some fast tape or other Teflon tape and line the threads of all the different fittings that we're going to be doing today. It's just a recommendation if you're in a hurry or in a pinch. This is a low pressure application. We're underneath 5 psi at all times, and so you may not necessarily need to have a very tight air seal. The next thing we're going to thread on here, this is a bushing. This will go from 1/4 inch to a 1 inch threaded. And so this is a 1/4 inch female pipe thread to a male 1 inch pipe thread. And then we're going to thread that into the next bushing actually. And so this bushing is going to go from 1 inch female pipe thread to a 1.5 inch slip or spigot connection. After that, we're going to use a coupler here. This coupler is for 1.5 inch piping, and so we're going to put that on there on the end there of the 1.5 inch spigot connector, and tighten that down so that way we get an airtight seal, or at least tight enough to hold in 5 pounds of pressure, up to 10. That uses the flathead screwdriver pipe clamp. We're going to get this 1.5 inch interior diameter by 2 foot length pipe. This is equivalent to 750 milliliters of air, our volume that could fit in there, and so we'll use that as a starting point. This also acts as an expansion chamber to help act almost like an air capacitor with what we're doing. And so here we go. You've got the 1.5 inch pipe wedged into the coupler. We'll just tighten that down with a flathead screwdriver on that end as well. You'll notice the materials form a pretty good seal. It's actually a little hard to get in there if you're in a pinch. You could use some soap and water or hot water if needed, but you're trying not to deform the shape of the pipe. It needs to create a seal. The vinyl pipe will stick to the rubber coupler pretty well and make a pretty good seal, almost like a gasket on its own, due to the coefficient of friction between the materials. The next thing we'll take a look at is getting a drill. We're going to make the bleed-in port for the oxygen system, and so to do that, we've got a 1/4 inch barbed connector. You're going to want to get your drill and find the right drill bit. Pick a size that matches the 1/4 inch barbed hole requirements. It should be just a little bit smaller than the barb tip, and luckily, since we're using this vinyl pipe, it should be able to press in there, and you should be able to install the barb with relative ease and hold a seal. That's why we didn't use a hard PVC pipe, although you can if you've got time to thread in a 1/4 inch barb. We've noticed that the air oxygen bleed-in line is a 1/4 inch line, and that's 1/4 inch outside diameter line. There's the barb, and there's the 1/4 inch line that we found to use. That'll connect to our 1/4 inch on-off valve. So take the drill, you drill your hole in, put the barb in, connect the 1/4 inch line there. Next thing we're going to do is get the next coupler, and we'll put that on the front end, similar to what we did on the back. Needs a good wiggle every once in a while. Again, we'll need a flathead screwdriver to tighten these pipe clamps. Make sure you tighten everything. I have had a couple times where I forgot to turn the pressure down and hooked it up to the air compressor, and the couplings weren't on tight enough, and it gave us a nice little pop. Startled me pretty good there, but luckily it's low pressure still. Alright, here we got the next 1.5 inch spigot to female 1 inch thread. This is the next bushing. We'll put that in on the end there and use this. I'm going to loosen this up a little bit because it's still a little too tight to get that bushing in there. So tighten that up. From here we're going to take the 90-degree elbows, so use threaded fittings again. Like I said, we don't have to worry about cure times. It is low pressure, but there's still some pressure in the system, so we can't just use regular pressure fits, as it might pop off. So the threaded fitting here again, put your fast tape on the threaded connections if you want to. It helps with the seal. These ones have some residual white Teflon tape on them that I had left over from assembling and reassembling the device a couple times and modifying it. So take the two 90s, we're going to be making a U-shape, and so what we're doing is reducing down the size of the pipe from the expansion tank to a 1 inch pipe size, and the 1 inch pipe size will there reduce down when we get to the end of the inhale circuit. That's what we're building here, is the inhale circuit. The 1 inch pipe will reduce down to a 5/8 inch line. So I've got two 90-degree elbows that we've threaded into each other. Obviously, the threads allow us to keep our installation flexible. You can change the orientation of the device at any time, and it won't impact the functionality of it, since we're just moving air and not water. So taking a look at this, the next device there, we've threaded in a 1-inch coupler or nipple. And then taking a look at the valve here, we're checking to make sure that the valve is going to flow in the right direction. There's an arrow on the bottom of the valve that shows which way the flow should go. And so I need to make sure that the air is going to flow in the right direction. We've threaded it on there with the flow going out. So that threads right onto the 1-inch coupler. And you can hand tighten everything for this device, and it should hold seal just fine. And we'll have to do the wiring for this valve shortly, and you guys will see that. So this is a zero resistance solenoid valve. That's the zero differential solenoid valve. That's the important thing that we're trying to make sure you guys utilize. We'll get it. The next coupler here is a 1-inch nipple again. So just hand threading that in there. And then we have this 1-inch ball valve. And the 1-inch ball valve, the intent of this ball valve is basically an emergency shutoff. So if you're in a situation where the patient looks like something's going wrong and you don't want to touch the PSI and you don't want to touch the timer, this is where we're going to look at just closing the ball valve. No more air in. Just close it off entirely. Shut it off. It's like those big red stop buttons you see at a gas station. It's kind of the same idea. Just want to have a big off valve that I can just reach up and shut off immediately without having to unplug anything, turn some dials, worry about going the wrong direction. The valve's either on or off. And so I've got the next 1-inch coupler there, or the nipple from the ball valve, and we're going to attach the threaded pipe thread 3-way T. That's threaded on there, and the next devices we'll be threading in are these bushings. These are 1-inch to 3/4 inch bushings, because our 5/8 inch barbed connectors use a 3/4 inch threaded connection. So threading in the next bushing, I wasn't able to find off-the-shelf 1-inch male thread to 5/8 inch barbed fittings, and so this is how I was able to adapt that. So we're taking the 90. This is for the emergency pressure vent, and so this is going to be threaded in there into that 3/4 inch bushing, and then the next straight barb is going to be going. That's the air outlet. We're going to be threading that into the next 3/4 inch bushing. I've got a third one there, and we're going to use that in a little bit, but we'll finish connecting this up. This is that 1/4 inch on-off valve I told you guys about. We'll use that to shut oxygen on and off if you're going to bleed in oxygen. Here's a typical oxygen port. You can see there that it fits the 1/4 inch outside diameter hose. That was cut from the ambu bag. If you do need oxygen, I recommend you just cut the tip off and feed it into the 1/4 inch on-off valve. Next thing we'll take a look at, this is 5/8 inch interior diameter hose. It has a 3/4 inch exterior diameter. I'm going to measure it here for you and show you guys. It's just a little under 2 feet. The thing that's important here to remember is we're trying to keep the hose lengths as short as possible in regards to the exhaust vents, both on the exhaust or exhale circuit, expiratory circuit, and on the emergency vent. So that way there's less air volume to worry about moving, and less air volume residual on the lines at all times. This is the inspiratory hose. We've used a corrugated dishwasher hose that we've found because it matches the compliance requirements, and so the hose won't shrink or flatten out or kink or expand with air pressure. It holds air pressure a lot better and is more flexible than the vinyl. The hoses usually come with a 90-degree rubber boot, and they can be cut to fit. And so I took the razor there and cut it so it fits a 5/8 inch barb, because you don't need the 90 unless it's required. What you'll notice is that the fittings should barb right in because the interior diameter of this dishwasher hose is 5/8 inch. This is a 6-foot, 5/8 inch interior diameter dishwasher hose. So we got the end of the hose now. You can see where we've barbed it into the inspiratory side or the feed side of the circuit. I'll show you here real quick how this hooks up. So I got a Y here. I know I specified a T in the parts list, and the only reason I've done that is because they sold the Ys in minimum packs of 10, and that makes them $30 unless you need 10 of them. And so I did buy 10 of them because I was playing with this, and also I would use them in plumbing around the house later on. The next thing I've got here is the exhaust side of the circuit. So this is considered a Y circuit. And so the exhaust side of the circuit, you definitely want to keep that as short as possible. You see that I only had about 3 inches of vinyl on, tubing there. This is the exhaust valve, solenoid valve. Again, we're going to be looking at the airflow in and out. So the direction we're going to be flowing air out, as it's the exhaust circuit side. So I'm threading in the bushing with a 5/8 inch barb, so it feeds air in to this valve and then out to atmosphere. So 3/4 inch bushing is threaded into the 1 inch valve, followed by 5/8 inch barbed. The circuit, you'll notice that it's much shorter on the exhaust side or exhale circuit, and that's because the typical ambu bag will have the exhaust basically 6 centimeters away from the mouth. What you're trying to do is reduce the amount of air volume and pressure required to vent out the exhaust exhale. So I'm going to be working on the wiring next here. We've got the wiring for the zero differential valves, and the wiring, you're going to have to take off the little control module on the back there. It's not too hard to do. There's one crosshead screw, and it's the same size screw. We're going to be basically the same screwdriver that we're going to need for the rest of the project as well, so we don't have to have a bunch of different crosshead screwdrivers or Phillips screwdrivers. There's a little quick push black pin in the end that I use the needle nose pliers for, and you'll take a look at that. You'll see that that collapses down. Wiring this, there's 3 connectors in there, line, load, and neutral. And so we're going to be wiring this up, but I'm going to use a simple, more of like a DC kind of configuration. I'm going to be looking at a positive and negative. And so I know I'm using a 24 volt AC power adapter for this, but these valves do come in several configurations in which you can do AC or DC voltage depending on your application. Along with the timer is suitable for AC and DC power supplies. So getting wiring, I just wired some lamp cord. This is just 18 gauge to 20 gauge wiring that I've got right now. This is not a high wattage or high voltage application, so you don't need anything too heavy duty. But you'll see I cut 2 different lengths. I've got a longer length for the expiratory circuit and a shorter length for the inspiratory circuit. This is where all the wires are plugged into the socket here. This is the timer controller. Socket is super handy. Makes it really easy to do the wiring because we'll just have terminals that we can screw down into. So once you've got your wiring all squared away, I'll show you guys how the wiring should be set up in regards to the socket and what goes where on the solenoids. So first thing I need to do though is clear a little space on the workstation. Getting a little crowded here on the little table with the camera and everything else in the way. And so I've got the controls here, like I said, or the power for the solenoid. What you'll notice is there's one port that's near the LED and one port that is near the resistor. I'll zoom in and take a photo and show you guys what that should really look like, which port basically I'm feeding these into. And so once you've got the wiring, I cut the wiring, stripped the ends off using the needle nose pliers. You just want maybe 1/8 of an inch to 1/4 inch of wiring exposed without insulation. And you'll feed that in to the little screw terminals that are on the back of this. Tighten it up, try to keep any wiring from touching anything else it shouldn't. Make sure it's fed all the way in so the insulation is butted up against the housing and no wiring is exposed or may come loose or bounce around and short out. So I'll feed this wiring back through plastic housing here, and you'll notice that there's 3 tabs in the orientation. The lower horizontal tab will be the bottom, and again I can show you guys a picture of that or zoom in on that. So feed the wiring in, make sure it lines up, and it just pops back in. Make sure the wire's not jammed in there. So this is the longer circuit, so this will be for the expiratory or exhale side of the circuit. Same process, we're going to work on the inspiratory circuit, and so we're going to take it out. It's the same leads and the same lead locations, and so again I've taken this time a shorter section of wire, as it just reduces the clutter and the wiring that's required for the project. Notice that you don't move the inspiratory side or the main components very often as much as you would move the 6-foot hose and the expiratory circuit side. Alright, now that when we finish up the wiring for both of the zero differential valves, the control solenoids, we're going to be setting those aside. We'll plug those in, but we're going to connect them to the socket for the timer and relay controls. Again, there's the socket. I'll show you guys a diagram here. It shows where the wiring needs to go to which port, and so keeping it consistent. I'll give you guys a quick heads up on how they go together, but we just use the Phillips screwdriver here as well, or the flathead, depending on whichever one you've got available. Loosen up the terminals and connect the wires to their appropriate terminal ports. Alright, the next thing we're going to want to put together is going to be the power for the timer controller. What here I've taken a lamp cord, just a regular 2-prong lamp cord. Use the needle nose pliers, cut off the end if you need to, if it doesn't already have the leads exposed. Split them, take off some insulation from the wiring, expose some of the conductors inside, and twist them so that way the wiring is not exposed. And so I'm going to plug these leads into the socket as well, into their appropriate locations. And again, I'll show you guys that diagram. You can see where these go. I've just used the colors here, but you're mainly looking for your line and load side, and getting that where that needs to go. The next item we're going to wire up is going to be the power supply for the zero differential valves. In this one I just took the Orbit sprinkler controller as a 24-volt AC power transformer that I had available. The valves that I purchased were 24-volt AC valves. We were trying to stick with the existing power supplies and off-the-shelf items that we found in the irrigation plumbing section of the store. And so I cut off the end there, exposed the leads. You'll see the wiring usually has 2 conductors on there. One's going to have a stripe on the insulation jacket, the other one does not. And so I've put the insulation jacket that has a stripe in it into the appropriate terminal here. Again, I'll show you guys that diagram, making sure that you get the wiring correct, make it very easy for you. Once I have all of the wires in their appropriate terminals, we're going to plug the timer into the socket. You'll notice the socket has basically like a dog ear, and so there's only one way that you can install this. They've made it easy so that way you can't mess it up. Just follow the socket orientation, plug it in. I'm going to set the timers at 1 second inhale, 2 seconds exhale, and just trying to make sure that those stay consistent for our settings going forward. We'll use that as a starting point. And obviously adjust from there, but that should be the safe settings for about 80% of our needs. Alright, and so I've got the wires all configured. I need to plug the solenoid controllers into the solenoid valves. And so you'll see here, I'll bring the unit back up. We'll plug it in. Remember, the longer cable was for the expiratory side. The shorter cable is for the inspiratory side. Basically, the inlet is there. So I'll plug the shorter cable into the inlet one. Tighten that down. And then we'll tighten down the outlet side or exhaust side of the circuit. My next objective, I'm going to be cutting the holes in the lid of our bucket, and the bucket's going to serve as our emergency vent, provide us with the centimeters of water we need for resistance. And so to do the bucket lid, first starting with the grommet, I've got a grommet that holds a 1-inch pipe. Sometimes the grommet, the lower section is too hard to get into the bucket lid, so I've taken a razor blade and cut that. We just need to add a little bit of friction to hold the pipe. That's all we're really looking for here. It doesn't need to be an airtight seal or anything like that. It just needs to hold the exhaust pipe in the water and keep it there at a specific height. And so I measured the grommet, traced it around the lid, drilled a pilot hole in the middle, and you can see the little coin that I cut out of there. You want it to be the right size for the grommet. You can use a razor blade to cut out the rest, or a Dremel tool, something that you can use to cut it out enough that the grommet will seat in there correctly. I then switched out the drill bit for a larger drill bit, because we're going to need some exhaust venting holes. We can't keep back pressure of air in the bucket. It'll end up gurgling out or causing issues. And so I've got this here. I drilled in 1/2-inch holes. I drilled in several 1/2-inch holes just to allow exhaust out. I shouldn't have an issue exhausting out of that many 1/2-inch holes. And so you can see that obviously the inlet side there, you're going to press the grommet in place until it's snug. And then I've got the 2-foot sprinkler riser here. This is a 3/4 inch sprinkler riser. It's a 2-foot length. What I've done is I've measured out 30 centimeters. So basically when the tube is at the bottom of the tank, or at the bottom of the bucket, it will have 30 centimeters of water for me. And I'll show you guys what that is in inches, along with a couple other significant measurement marks. You can mark the pipe. Once you're done marking the pipe, you want to thread on your riser connector. So this is a 3/4 inch coupler for a riser, because remember, I'm using another 3/4 inch male thread to 5/8 inch barbed connector there. And so it basically is going to slide the riser into the grommet. You can see how it holds. And so I've marked that line there where the top of the line should be, and that gives me 30 centimeters underwater. Mind the air gap at the top of the bucket as well when you're marking it. And so I'll show you guys here how this sits in the bucket. And so you'll see it just goes in the water there. Make sure we got 30 centimeters of tube depth underwater, actually underwater. So make sure you mark that pipe correctly. Fill the bucket up where you need to. What that basically says is there needs to be a minimum height of water in the bucket, which should be the number of inches that we specified. We're going to hook up the emergency exhaust vent to the inches of water. So what this basically is doing is providing an overpressure relief valve for the system, meaning if there's too much air pressure in the system, we don't want to hurt anyone or pop my lungs or anything like that. And so what I'm going to do is allow the gas to escape in a safe way, but a controlled way, out of our system. And so I'm using this water bubbler to accomplish that goal. You can see where it feeds off of there. That's that 5/8 inch hose, that clear flex hose, and it's just plugged into both of the barbed fittings. I'm now going to connect the exhaust, or the inspiratory circuit, back onto the Y using the 6-foot corrugated dishwasher hose. I'm going to start looking at plugging the devices in so we can start testing it, making sure everything works before we connect it to myself or any other persons. And so we'll be able to hear the valves cycling and the relays clicking on and off, and make sure that everything's energized before we plug any air into it. So you can hear the relays clicking, 1 second on, 2 seconds off. Now I'm going to hook up the air and make sure that, first thing, obviously, make sure the air is all the way off before you hook up any feed source on the regulator, and then slowly turn air on, feed air into the system, slowly feathering it into about 4 psi. That's going to be the safe range for us. Starting there, so I've got 4 psi on the gauge there. You guys can hear what that sounds like. As well as checking the system. So we're going to check back pressure on the system. I'm going to put my finger over the port that would normally go out to the patient or myself and make sure that it's putting back pressure in the system and that the emergency vent is going to bubble and vent out the exhaust air as it's supposed to if there's too much resistance or air pressure in the line. You'll also be able to hear the air come out of the exhaust. Take a look at getting the filter on there. That's the 15 millimeter and 22 millimeter viral filter or particulate filter. We want to make sure there's no bad stuff going in or coming out of the system that's going to me or the patients. Obviously, it fits the 5/8 inch line, similar to the other fittings that we've got there. We're trying to keep the same size line throughout the circuit, so that way the gas volume has as little resistance as possible or changes in pressure or flow. So this is also the 5/8 interior diameter line. I cut a small piece there. And am fitting on the filter, which would then connect to either an intubation tube or a mask of some kind. I'm going to turn the gauge around here so you guys can see. Obviously, like I said, everything is hand tightened. It's holding pressure, so I can just swing the gauge around without any tools required. But you can see there where it's bouncing a little bit over 4 psi. So I'm going to feather that back down a little bit here. Remember, test it, check it, make sure it's working correctly before you actually use it. And so you can see here where it's pinging where it should. It starts at 4, pressure equalizes somewhere around 1, 1.5 total, and also vents out anything extra.